All right, this is lesson 8.4, dilations. This is our last lesson for chapter 8. Here's our objective. So given a dilation, you should be able to tell whether it's an enlargement, a reduction, or a congruence, and you should also be able to tell the scale factor. The first blank here is a dilation, is a transformation that may change the size of a figure. Even though it says may change, it usually will. Otherwise, it's not very interesting, right? It just stays exactly the same. Here's our second fill in the blank. All the transformations we've learned so far. So translations or slides, reflections or flips, and rotations or turns. We've seen those already in 8.1, 8.2, and 8.3. Those are all rigid transformations because they produce congruent figures. The image and the pre-image are exactly the same size and shape in those three. However, for dilations, that's not the case. A dilation of magnitude, of magnitude A, is defined by this rule here. And I'm going to go ahead and add some notes. Let's put it in blue like the rest of it. There we go. So this little A here, it can be any number you want. This is a dilation about the origin. So it's really important that you know, if you want to use this rule, you are setting the center point for this dilation to be the origin, the point 0, 0. And the scale factor, oh, not that A. The scale factor is A. That A there. All right. So this means the pre-image size is being altered. It's stretched or being shrunk. And our blank here is the word similar. So when we stretch or shrink something, we have similar figures, but not necessarily congruent ones. In fact, the only time your pre-image and image will be congruent is when your scale factor is equal to 1. That's when the image stays the same. Otherwise, if the scale factor is less than 1, then the image will reduce in size or shrink. If the image is greater than 1, if the scale factor is greater than 1, then the image will be bigger than the pre-image. All right, so let's get right to the examples. We're going to plot the pre-image in black. You can pick whatever color you want. I'm going to do it in black. So A is at 1, 1. B is at 2, 3. C is at 4, 2. Right there. And D is at 3, 1. So here is our quadrilateral A, B, C, D. And go ahead and use this rule. Since it's a dilation about the origin with a scale factor of 2, we're going to take every coordinate that we had for A, B, C, and D, and we're going to map it to 2 times x for the new x coordinate and 2 times y for the new y coordinate. Give that a shot, fill those in, and then come back and check your work. All right, so hopefully you doubled every coordinate. And let's go ahead and plot these points now. The points for our image. 2, 2 is right here. 4, 6 is right here. 8, 4. There's the coordinates for C prime, and then D prime is at 6, 2. So it should be right here. So there's our A prime, B prime, C prime, and D prime. And hopefully you can see that the shape stayed the same in our pre-image and image. It just stretched and got bigger. Okay, so remember how I said we don't always have to have a center at the origin. We can have a center of dilation at other points. So I'll mark this in green. For example 2, we are going to use the point 0, 2. This green dot right here is going to be our center of dilation. And because that's not the origin, we cannot use the rule we had on the last page. We're not just going to be multiplying all the coordinates by a half. The other thing is, there's a typo here. Can you please change these? Let's put Q at -4, -4. We'll put R at 0, 8, and we'll put S, let's say that's at 4, 2. This will make a bigger shape. That way when we shrink it down, it's not too small and we can still see where it is. Go ahead and plot the coordinates of our pre-image now. I'm going to use pink this time because I made a typo. Q is going to be at -4, -4. Right there. R is going to be at 0, 8. Right here. And S will be at 4, 2. Go ahead and draw your triangle. That's going to be our pre-image. And then our image has a scale factor of a half, but I cannot just say that Q prime is -2, -2, cutting those in half, because my center of dilation is not the origin. So instead, what we'll have to do is we're going to find the distance from Q to the center and cut that in half, and that, because our scale factor is a half, and that'll be the coordinates of Q prime. So actually, let's leave it there for now. To get from Q to our center, which we called C, we're going to have to go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. Let's just cut both of those in half. I'll go up half of that distance, so 3. I'll go to the right. Half of 4 is 2, which would put us right here, and I'm going to put a point there. That's going to be the coordinates of our image, or Q prime. That's going to be at -2, -1. All right, let's do the same thing for R. R is 1, 2, 3, 4, 5, 6 points above our center of dilation. So if we go 3 points above our center of dilation, we'll find where R prime should go. And then S is 4 points to the left of our center of dilation. So 2 points right in the middle of S in the center. That's going to be our S prime. We can draw our triangle for our image. Where is that? R is going to be at 0, 5, and S will be at 2, 2. All right, notice XY did not end up going to 1/2 X and 1/2 Y. Again, just because our center of dilation is not at the origin. Oh, in fact, one more thing. This is a good picture because I might give you a slightly different problem in the future. I might ask you, where is the center of dilation? So if I were to give you the pre-image and the image, but let's pretend like that green dot isn't there, and I ask you to find the center of dilation, we can do that as long as we remember that the coordinate Q prime is halfway between the coordinate of Q and the center of dilation. In other words, all these points are, the fancy word for this is collinear. So I can think of Q, Q prime, and the center of dilation are all on the same line. But that's not just unique to Q and Q prime. That's the same for R and R prime. R prime, and the center of dilation, they all line up as well. And so these two yellow highlighter lines I'm making, they cross at the center of dilation. So we can find out that it's at the point 0, comma 2, even if that point wasn't there for us. Or similarly, S prime, draw the line through them both, and we'll hit the center of dilation as well. Okay, moving on. If you know corresponding measurements for a pre-image and its dilation image, you can find the scale factor. So this is a good formula to write down in your notes. The scale factor is the image length divided by the pre-image length. So remember the image, that's like, oh, actually the image is after, right? This is our after, and this is our before. The cool thing is there's lots of different lengths you can choose from, and you'll get the same scale factor either way. So if you want to add a little note here, we can say we can choose any two corresponding there we go, corresponding lengths. I'll show you what I mean by that in a moment. Let's take a look at number 1 here. We're saying that CGHJ is the image. It's a dilation of this pre-image, CDEF. So there's our pre-image in black. After we perform the dilation, we have a larger square. This is definitely an enlargement. And let's find the scale factor. The scale factor is going to be any image length we want. So I could pick CG, or I could pick GH, or I could pick HJ, or whichever one. I'm going to pick CG. But as soon as you pick that one, CG, you have to pick the length on the pre-image that corresponds to CG, right? So since I'm picking CG, the first 2 letters in the name, I need to pick the first 2 letters here, CD, and sure enough, that's the corresponding length in the image. All right, so that's going to equal CG. You can count up how long it is. It's 8, and CD is 4 units long. 8 over 4 reduces to just 2. So our scale factor is 2, where all the lengths are being doubled in example 1. Let's try example 2. Again, CKL. CKL, this triangle is our image. But wait a minute, it's also our pre-image. So the shape and size are the same. According to our notes on the last page, that means the scale factor has to be 1. Kind of already know that. But we could still pick CK, corresponding lengths, CK over, well, CK again. And CK is 4 units long. It's going to be 4 units long whether we think of it as a length in our image or a length in our pre-image. And 4 divided by itself, of course, is 1. All right, number 3. We have a hexagon. Hexagon STUVWX is the image, and it is smaller than our pre-image hexagon MNOPQR right there. So this is not an enlargement, this is a reduction or a shrink, and we can find the scale factor. What's kind of weird though is if I choose MN as the length for my pre-image, ST is kind of harder to measure because S and T, they're not on nice points. The cool thing is we don't have to pick side lengths. We can pick any length. We could pick the length from the center out to a point. In fact, let's go ahead and do that. So our scale factor is going to be a length in our image. I'm going to pick the length CU, which is 2 units long. I'll put CU for now, though. The corresponding length would be from the center, instead of U, it'll be all the way out to O, because O is the point on our pre-image. All right, so CU, we already said was 2 units long. CO, if you count it up, C and O are 4 units apart. So our scale factor is 1/2. All right, here's number 4. We have image CPQ, the small blue triangle, and pre-image CYZ. This one doesn't have any lines that are completely horizontal or completely vertical, which makes it a little more challenging, but we can do it. Let's choose CP, let's say, to be the length for our image, and then CY should be the length for our pre-image. Hopefully, you notice that CP is just one diagonal. It's like the diagonal of 1 unit square. If you're really good at the Pythagorean theorem, maybe you remember that from a different math class, you might know that the length of CP is the square root of 2. But you don't even need to know that. You could just call it, oh, that's one diagonal. And then CY, isn't that 3 diagonals? 1, 2, 3 diagonals, right? And 1/3 is our scale factor. All right, try 5 and 6 on your own, and then we'll be done with the notes for 8.4. Okay, here's 5. I showed you different ways. You don't have to do all 3. The first one in blue is the distance from the center of dilation to some point. I chose F. That's the distance to a point on our image. And the corresponding length would be the distance from the center to B, which is the point that matches with F, but B is the point on the image, on the pre-image rather. And that would be 6 units and 4 units. That fraction reduces to 3/2. So our scale factor is 3/2. Bigger than 1. That checks out because our image is bigger than our pre-image was. Here's some other ways to do it. You could do EG over AD, or even EF over AB. Here's 6. Again, the image is exactly the same as the pre-image, so our scale factor is 1. As always, ask a question at the end of the video, and I'll see you all in the next one.